Hi everyone, a very good evening to all. Now we are going to study about the question number 74, that is all about law of flotation or Archimedes principle. See, what is force of buoyancy? First we have to understand here. That is when a solid immersed in a liquid, it experiences it experiences it experiences an upward force, that is called force of buoyancy, and that force of buoyancy is equal to the volume of the solid inside, not complete volume, into density of the liquid into G. So this is called force of buoyancy. Whenever a solid is immersed inside the liquid, there must be an upward force. That upward force experienced by the solid body is called force of buoyancy. Now, what is law of flotation? When we immerse a solid completely inside liquid, where solid density is rho, liquid density is sigma, then if the total weight is greater than buoyancy force, that is density of the solid is greater than density of the liquid, then the body will sink. If W less than B, then rho less than sigma, then body will float. So this is the condition of sinking and floating. Now, so this is the condition, but whenever the body is floating, when body is floating, then the W should be equal to B because it is in equilibrium. Here W less than B means you completely immersed, but here when it is floating, it is not completely inside. Partially it is inside. In that case, W should be equal to B. So please don't get confused. Here floating condition W less than B, because when you immerse it and leave it, like you take a ball and completely immersed inside the liquid and leave it, then it will come up, because there buoyancy is more than weight of the body. But when you take the ball and leave it on the surface, then small volume is inside and still it is floating. That means buoyancy will decrease and it will become equal to the weight of the body. That is the meaning. Now, what is the fractional volume of floating body, in or outside? Now here, see, in case of floating, first thing, the buoyancy and W must be equal. That means V rho G should be equal to V inside sigma G, implies V inside equal to V rho by sigma. Then V outside will become V minus V inside. That is V minus V rho by sigma equal to V into 1 minus rho by sigma. Fractional volume inside, fractional volume outside. V inside by V is called fractional volume inside. V outside by V is fractional volume outside. Also, they can ask the relative density of a solid. They can ask, where relative density of solid means density of the solid by density of water. That means you multiply with volume and G. So V rho G is weight of the body. Here denominator is buoyancy force on the solid inside the liquid. What liquid? Water. Now you have to consider the buoyancy force on the solid inside the water. Or W by B also can be written as W minus W apparent, where W apparent is the apparent weight of the solid body inside the liquid. W is the true weight of the body inside the air, or else they can also ask the question based on relative density of liquid. Now relative density of the liquid means density of the liquid by density of the water. Now again you take one solid and immerse inside the liquid, then find the buoyancy force. So V rho Lg. And you take the same solid and immerse in water and find the buoyancy force. Now this is the buoyancy force in liquid, buoyancy force in water. Nothing but W minus W1, W minus W2. W is true weight of the solid, W1, W2 are apparent weight of the solid in liquid and water. So this way they can ask question based on relative density of solid or liquid, or apparent weight or tension in a string. That also they can ask. Like there is a support and one solid is hanging. Now you keep it inside the liquid. Then the tension nothing but apparent weight, that equal to W minus B, where W is true weight and B is buoyancy force. So this based formula also they can ask. This formula based question also they can ask. 1 minus B by rho means sigma by rho, where sigma is density of liquid, rho is density of solid. Now, so here already I have explained. So what is the relative density and how to find relative density of a solid and liquid. So the relative density of solid is buoyancy force, weight of the body by buoyancy force in water, that is nothing but W by W minus WA, apparent weight, or relative density of liquid means buoyancy force in liquid by buoyancy force in water, that is W minus W1 by W minus W2, where W is true weight, W1 and W2 are apparent weight of the body in liquid and water respectively. Now let's see examples based on whatever we have seen. Density of ice. So now the density of ice they have given, that is 900 kg per meter cube. A piece of ice is floating in water. Now water liquid density is 1000 kg per meter cube. Find the fraction of volume of the piece of ice outside the water. So V naught means V into 1 minus rho by sigma, where V naught equal to V into 1 minus rho is density 1000. Density of the solid, 900 ice by sigma density of liquid water 1000. So that it is V by 10. 1/10 volume is outside. That means inside how much will be there? 9V by 10. So this way they can ask fraction or percentage volume inside or outside. If they ask percentage, then you have to multiply with 100, just like VI by V into 100 percentage, or VO by V into 100, that is percentage volume outside. Now a piece of ice is floating in a glass vessel filled with water. How will the level of water in the vessel change when ice melts? So here they did not mention the density of the ice actually. So that you have to consider properly. Here let's take V is the volume of ice and rho I is density you consider. Now when ice floating, volume of ice inside is nothing but amount of liquid displaced. So that is V inside. How much it will become? Mass by volume. Mass by density. Mass, let's take M. Density rho. Rho ice. Now, when ice melts, M ice converts into M water. Now, volume is, let's say V dash, that is M water became by rho W. But here, when you consider the initially, Vi volume is inside. So that Vi amount volume of liquid got displaced, means water. So that volume of water displaced means that mass by density of water. So the volume of water displaced and the volume of water formed after ice melts, both are same. That's why whatever liquid got displaced, that remains same because ice melts and occupies the same amount of volume. That's why the level remains same. That is what the meaning of the question. Now here, a cube with an edge of 10 centimeter is immersed in a vessel containing water. A layer of liquid immiscible with water and having a density is poured above the water. The interface between the liquid is at the middle of the cube height. The mass of the cube is. So there is a cube. Let's take the cube. Now this is, let's say, one face of the cube, side length A, that is 10 centimeter. Now it is immersed in a vessel containing water. A layer of liquid immiscible with water and having density 800 is poured above. So less denser poured, so it will float. The interface between the liquid is at the middle of the cube height. That means it is exactly, this is the interface now. This is A by 2, then this is A by 2. Now this is water and this is that oil or liquid, some other liquid. That means now here how many buoyancy forces will act? One is due to liquid, another is due to water. So weight of the body will be balanced by now B liquid plus B water. Now weight means M into G. Buoyancy due to liquid means volume inside the liquid into density of the liquid into G plus volume inside water into rho W into G. G get cancelled. So M equal to volume inside the liquid means half into liquid density is 800 plus volume inside water is also half into 1000. If you take V by 2 common, V by 2 into 1800. Now volume means what? Cube means V equal to 10 into 10 into 10 into centimeter cube means 10 power minus 8. So 10 power minus 3 meter cube. So if you substitute, then you will get the mass. So 900 into 10 power minus 3 kg or 900 gram or 0.9 kg. So this way, when multiple liquids are there, you have to consider each buoyancy force due to each liquid. So each liquid will apply one buoyancy force. Now, a boat having a length of 3 meter and breadth 2 meter is floating on a lake. The boat sinks by 1 centimeter when a man gets on it. A boat having a length of 3 meter and breadth 2 meter is floating on lake. Just like you just take like a rectangle, 3 meter and 2 meter. Now there is some height also will be there. Now the boat sinks by 1 centimeter. Suppose initially water is up to this level. This is completely water. Now when a man gets on it, it will went down by some distance. How much? 1 centimeter. But area of the boat remains same, that is 3 into 2, 6 meter. Then the additional volume went inside or volume immersed or went inside is now 6 into 1 centimeter means 10 power minus 2. So 6 or 0.06 meter cube. Now this is due to the weight of the person. This is the buoyancy force now. So now the weight of the person is balanced by buoyancy. Weight of the person means mg. Buoyancy on the buoyancy due to the additional volume inside means what? V inside into sigma into g. So m equal to V inside into sigma. V inside is 0.06 into sigma. Density of the water means 10 power 3. So 60 kg. So this way, see, the question is based on the same formula, but the way of asking question is different. So the boat is like already something immersed. After you get onto it, something went down bore by a depth of 1 centimeter means some additional volume went inside means additional buoyancy force got developed. That must be balanced by what? Weight of the body. Then only it can sink, it can float on the water again. Now, same way, two bodies are in equilibrium when suspended in water from the arms of a balance. The mass of body is 36 gram and its density. The mass of the other is 48 grams. Its density is. Two bodies are in equilibrium when suspended in water from the arms of a balance. That means, see here, like you are suspending two bodies in water. Now both are balanced means apparent weight must be same. Apparent weight means true weight minus buoyancy. W1 B1 minus W2 minus B2. True weight of first one they have given. True weight, let's take WW. Two bodies are in equilibrium when suspended in water from the arms of a balance. The mass of one body is 36 grams and its density is 9 grams. Okay. Then weight of the body means volume into its density into G minus buoyancy force means total is immersed. So V1 water density only rho Wg equal to now V2 rho 2g minus V2 rho Wg. G will get cancelled. Then the formula will become V1 rho 1 minus V1 rho W equal to V2 rho 2 minus V2 rho W. Now here V1 you can take common, here V2 you can take common. Now V1 if you take common, rho 1 minus rho W equal to V2 if you take common, rho 2 minus rho W. Now V1 is, here I am writing, V1 is volume of first body, that is mass by its density into rho 1 minus rho W equal to V2 is M2 by rho 2 into rho 2 minus rho W. Rho W is known, rho 1 rho 2 given, rho 1 is given, M1 M2 given. What they are asking to find? Rho 2. So now you can substitute in this formula. So you can remember it like a formula also when two bodies are balancing from the ends of a balance. So this is how the question level can increase, the difficulty level can increase, or the direct formula based question they can ask. So this is how you need to understand how to apply Archimedes principle or force of buoyancy in solving numericals. So similar questions I have given as an assignment. Just try to understand and try to solve. So thank you all. We'll continue in the next session with the next class.